Now we're doing number 7, which is again, this is a parabola. We are given an equation. It is y squared equals negative 6x. Notice again that we do not have an h or k visible in our equation. Therefore, our vertex is at 0, 0. We are going to compare this equation to y squared equals 4px. Notice that the y squareds and the x are the same. And therefore, we can figure out our p-value by setting 4p equal to negative 6. We'll divide both sides of the equation by 4, and we'll find that p equals negative 3/2. Now, starting from there, we can get our our focus. Because this equation is in x, we know that it is going to be opening right or left. Because our p-value is negative, it's going to open to the left. So let's start by putting in our vertex at 0, 0, and then we are going to go 3/2 in the negative direction, and that will be our focus. And we can label those with an F and a V. Our focus then is negative 3/2, 0. Remember, our directrix goes in the opposite direction, the same distance p. Therefore, our directrix, we can draw in, actually that should be a solid line, at x equals 3/2. And that's x equals the opposite of p. Now, our parabola is going to be opening to the left, but we don't know exactly how wide it should be. Now, the way that you can find the width is by multiplying p by 2. 2p would be negative 6/2 or negative 3. We're going to use this 2p value, and we're going to go up 3 from our focus, and we're going to go down 3 from our focus. And we're going to use that to give us the width of our parabola. So our parabola will go through the vertex, through these endpoints, and towards the focus. So it contains the focus in the concavity of the parabola. The distance between these points, between the focus and the end point, is 2p. That makes the total distance between the endpoints 4p. And this thing, if you never heard of it before, is called the lattice rectum. The total distance is 4p, half the distance, so from the focus to one endpoint would be 2p. Remember, we found p from our equation, and p is also the distance between the focus and the vertex and the directrix.